Day 3 algebra. We are on day 2 of least common multiple, and we've got some questions on the homework. There should be some questions on the homework. Which ones would you like to talk about? Or should I just go over all of them and you can stop me as need be? Let's just do that. 3 and 8, the least common multiple of 3 and 8. Remember, we're not looking for greatest common factor here, right? We're looking for if I start counting by threes, 3, 6, 9, 12, etc. And I start counting by eights, 8, 16, 24, 32, etc. What's going to come up first? The least common multiple. You start counting, what's going to come up first? James?
24.
Eventually 24, yeah. 15, 18, 21, 24. That is the least common multiple. The first number that shows up in both lists. That's what we're looking for. Okay. The method we talked about in class, the table method, not really going to do us a whole lot of good here because they don't have any factors to pull out, right? But if that's the case, then all you have to do is multiply. Notice that 3 times 8 equals 24. If they don't have a GCF to pull out, then you can just multiply them, and that's going to be your answer. 10 and 15, though, let's use the table method for this one. Okay. What is a common factor between 10 and 15? Schleifer, 5. Okay, so we take out a 5, we divide by 5, we get 2. Divide by 5, we get 3. Can we take anything else out of 2 and 3? No. So what do?
Make a shoe and then
Make a shoe?
Or take the L.
We take the L.
My bad.
Least common multiple. It does look like a shoe, yes, but I like take the L better.
Like
Take the L. Least common multiple. We multiply all these together. 5 times 2 times 3 equals 30. So 5 was a very common wrong answer on the homework check, right? And so what that represents is the greatest common factor. Okay? But with least common multiple, we take that L. 5 times 2 times 3 equals 30. Okay. 14 and 21. Let's make our table here. 14, 21. What can we pull out? We can take out a 7, right? So then divide by 7, 14 divided by 2, or divide by 7 equals 2. 21 divided by 7 equals 3. Anything we can take out of a 2 and a 3? No. So what do? Take the L. Right? And 7 times 2 times 3 equals 42, and that is the LCM. Okay? Are we jotting these things down?
I'm good.
Okay? Jotting these things down. 6 and 24. What'd you get for that one? Anyone want to share there?
6.
Bennett, 24 is the correct answer. Do I need to talk about it? It uses some more class time if I talk about it.
Sure. We have to talk about it.
Okay. 6 and 24. You notice 6 goes into 24, right? So that's a hint. If I start counting by 24, 24 is my very first number listed. If 6 goes into 24, 24 is also a multiple of 6. But for the viewers, for the subs, we will do the table method. You can get your money's worth. What can we take out of 6 and 24? 2. We could do a 2. Okay. 6 divided by 2 equals 3. 24 divided by 2 is 12. Can we take anything else out? Now? Of 3 and 12? Yeah. What? 3. Okay. So take out a 3 to add another row to my table here. 3 divided by 3 is 1. 12 divided by 3 is 4. Can I take anything out of 1 and 4? No. So what do? Take the L. And 2 times 3 times 1 times 4 equals 24.
I did. Dang it.
Yes.
I did 6 and then 1 4.
Had you taken the 6 out first rather than 2,
too.
it'd be the same thing, only it'd be 6 times 1 times 4. Still 24. Doesn't make a difference. Which is the beauty of the table, and that you don't have to take out the greatest number possible, right? You can just have to take out something and keep working it down until you get to There's no other option. Yes?
I forgot to put the 1 there. So I just thought it was 0. The answer's 12.
Oh, gotcha. Yeah, sure. Okay. That happens. It happens. So then, did you fix it? Good. Okay. Next row, 66 and 99. Let's take a look at these two using the table method. What can we take out of 66 and 99? 11. 66 divided by 11 is 6. 99 divided by 11 is 9. What can we take out of 6 and 9? We can take a 3. Add another layer here. Keep working it down. 6 divided by 3 is 2. 9 divided by 3 is 3. Anything we can take out of 2 and 3? Ethan, what do we do now? Take the L. Right? 11 times 3 times 2 times 3. 198 is the least common multiple. Okay? And this is why it's important to show work also, right? So you can see how we get to that answer. 25 and 35. What can we take out? Logan. What can we take out of 25 and 35? A 5. 25 divided by 5 is 5. 35 divided by 5 is 7. Anything we take out of 5 and 7? What do we do? Take the L. And 5 times 5 times 7, or essentially 25 times 7, is 175 is the answer that you should have. So if you put 5 for this one, right, you found the greatest common factor, which is part of it. You just didn't take the L. Take the L. 80 and 50, this was on the homework check. It is 400. Do we need to see it done?
No. Yes.
Not wasting time. We are doing productive things. It just takes time. Not wasteful, though. What can we take out of 80 and 50? 8. 10. 80 divided by 10 is 8. 50 divided by 10 is 5. Anything we can take out of 8 and 5? No. Take the L. 10 times 8 times 5, or essentially 40 times 10 is 400 as an answer. Okay. 3, 6, and 11. These 3-numbered ones can be a little bit tricky because the rules change a little bit from greatest common factor, which remember it's not greatest common factor, so that's okay. But when we look at what we can take out now, it's not all 3 numbers. It's what can you take out of any of the 2. Right? So 3, 6, and 11, there's nothing we can take out of 3, 6, and 11. However, what can we take out of 3 and 6? 3. So we still do that. Okay? And when you divide, 3 divided by 3 is 1. 6 divided by 3 is 2. 11 divided by 3 can't be done, so we don't. We just keep it as 11. Okay? But this is where 3 numbers can be a little bit tricky because that process changed. And so now, because there's nothing that can be taken out of anything, 1, 2, or 11, here's where we take the L. And so it's 3 times 1 times 2 times 11, which is 66 as an answer. Okay? If you got 198, you got that by multiplying 3 by 6 by 11. Okay? You were close, but you got to take out what you can. Any of the 3. Yeah, 8. It'll cost you a pass. It'll cost you a pass. Okay. He knows. He knows. Anything else with this one? Okay. Next 2. Similar thing. 8, 16, and 14. It was on the homework check, but we'll talk about it. 8, 14, 16. What can we take out of any combination of numbers here? 2. All right. 8 divided by 2 is 4. 14 divided by 2 is 7. 16 divided by 2 is 8. Can we go any further?
Yeah.
Yes. This is least common multiple. Anything we can take out, we take out. Even though it can't be taken out of 4, 7, and 8, what can we do with the 4 and the 8, James?
Divide by 4.
We can take out a 4, right? So this becomes a 1. The 7 we can't do anything with. That's okay. Just still a 7. Then 8 divided by 4 equals 2. Now we take the L.
That's a big L.
It is a big L. And 2 times 4 times 7 times 2, what would we come up with? 112 as an answer? There you go. Okay. Last one, 12, 15, and 20. Same deal here, 3 numbers. What can we do? So we haven't heard from yet today, perhaps. What can we take out of 12, 15, and 20? I say 12, 15, or 20. Nothing can be taken out of all of them. So you gotta work. Liv. 2. 12 divided by 2 is 6. 15 divided by 2 can't be done. 20 divided by 2 is 10. Are we done? No. What can we do next, Schleifer?
Take a 5.
Take out a 5, because a 5 can be taken out of 15 and 10. Not the 6, but that's okay. It'll still just be 6. 15 divided by 5 is 3. 10 divided by 5 is 2. Now are we done? This is going to be a big ol' L. What can we take out now? 6, 3, and 2. We can take out a 2, right? So let's do that. 6 divided by 2 is 3. 3 divided by 2 can't be done. That's okay. Let's drop it down. And 2 divided by 2 is 1. Now are we done?
No.
What can we take out now?
3.
A 3.
Oh no.
3 divided by 3 is 1. 3 divided by 3 is 1. The 1 just drops down. We've taken everything out we possibly can. Okay? 1, 1, 1 at the bottom.
Oh yeah.
Okay?
That's an L now.
That's an L. There's no denying that. 2 times 5 times 2 times 3. We get 60 as an answer. And that is the least common multiple. Okay? That is the least common multiple. Questions on this stuff? Again, the homework check wasn't great. Don't close your binder. We're not done fixing yet here. Yeah, well, the next page is just the same thing, just word problem. You're using least common multiple. You can do this. You can do this. Okay? So the second page. You've got some word problems here. It says, Pat, Mark, and Chris take off from the starting line on a race track at the same time. Pat can run a lap in 2 minutes, Mark can run a lap in 5, and Chris can run a lap in 7 minutes. How long will it be until they're all together at the starting line of the track once again? So remember with greatest common factor, with the word problems, we underlined certain phrases that told us we were using greatest common factor. Who can recall? What were some phrases with greatest common factor word problems we were looking for that told us this is GCF? Liv. Identical. Not all together, but all. It didn't include the word all. The greatest common factor, using all the items, right? Identical piles, using all the items. Same piles, right? That's the thing. Identical piles using all the items. That was your greatest common factor. Okay? There are some phrases for least common multiple as well, right? When things start at the same time, and here's the all together, right? All together once again. When something starts at the same time, and you want to know when that will happen again, that's least common multiple. Okay? Because if we've got Pat, Mark, and Chris that are running this race track here, okay? It says that Pat can run a lap in 2 minutes. So if they all start at exactly the same time, Pat will get back to the starting line after 2 minutes, after 4 minutes, after 6 minutes, 8 minutes, 10, 12, 14, etc. Right? Every 2 minutes, there's Pat again, back at the line. Mark runs a lap every 5 minutes. So if Mark leaves at the same time as Pat, Pat's running faster than him, but Mark can just come back to the starting line. 5, 10, 15, 20, 25, 30, 35, 40, etc. Okay? Chris is taking his time. He comes back around every 7 minutes. So if they all leave at the exact same time, Pat comes back at minute 2, Mark at minute 5, Chris at minute 7. Are they all back at the line at the same time here? No. At minute 14, who's back at the line together again?
Pat, Chris.
Pat's there. Chris is there, but not Mark. Right? So they're not all together again. So we continue on. 21, 28, 35. Oh, 35. Mark will be there at 35. Chris will be there at 35. Will Pat be?
Yeah.
No.
Oh, wait.
Right? And how do we know that without having to continue this on all the way out to 30, 35? Because every even number, Pat's there. It's counted by 2. Who's 35 being odd, Pat isn't going to be there. So really, we just got to figure out at what even number will Mark and Chris be there together? Because we know Pat will be there because he's every single even one, right? So let's continue this out here. 35, 42, 49, 56. Will Mark be? How do we know Mark won't be there at 56?
It's not a 5 or a 0.
So it's counted by 5, right? So essentially multiples of 2, multiples of 5. The 7 is the wild card here. 63, 70?
Yes.
Yeah, right? Mark, if we extend his out, 55, 60, 65, boom, 70. I'm not going to write Pat's out, but since it's even, eventually he'll be at 70 as well. Okay? So, our clues. Something happens at the same time. When will that same thing happen again? That's least common multiple. And it will happen 70 minutes later. If you had used the table, you would have essentially multiplied 2 by 5 by 7. You'd get 70 that way as well. Okay? So, word problems, are they trickier than just giving it to you? Sure. But once you recognize what you're looking for, you recognize what the concept is, then it really is just given to you. It's like giving you the numbers, you know what to do with them. Okay? Did I see a hand up when I was talking about that? Are we all good? Okay, next one. 4 ants leave their hill together. All 4 return and then leave again in the following manner. The first every hour, the second every 2 hours, the third every 3 hours, and the fourth every 4 hours. At what time will all 4 ants be at the hill together again? Something happens. When will it happen again? Least common multiple. What numbers are you finding the least common multiple of?
2, 3, and 4.
Well, essentially 2, 3, and 4, but technically 1, 2, 3, and 4. But since 1 goes into everything, and yeah. Okay, so you've got the numbers. LCM of 1, of 2, of 3, and of 4. You count by 1s, count by 2s, count by 3s, count by 4s. What number's popping up first? Okay. 2 stoplights both turn green at 1:05 p.m. Something happens. It takes one stoplight 20 seconds to complete a cycle, which means going from green to yellow to red and back to green again. And it takes the other stoplight 36 seconds to complete a cycle. At what time will both stoplights again turn green together? LCM. Something happens. When will it happen again? Okay. What do you find in the LCM of?
20 and 36.
20 and 36. It's a word problem, yes, but once you identify what's my concept and what are my numbers, now it's just like what you did on the front side, basically. Okay? Although this question is at what time. So when you get your answer, you'll have to say, that's how many seconds it takes. What time is that? If it happens at exactly 1:05 p.m., what time will they once again turn green? Then Mr. Schultz eats tacos every 4th day and buffalo wings every 9th day. Every so often it happens that he eats tacos and buffalo wings on the same day, and I call these buffalaco days. Approximately how many times a year do I have a buffalaco day? Okay, so something happens, right? Every 4th day, every 9th day, when those two things collide, we have a buffalaco day.
You actually do that.
Would I ever lie to you, Lincoln?
Yes.
Just that's my red flags. Okay. Every so often we have these buffalaco days. How many buffalaco days will I have in a year? And guess when the next buffalaco day is? Thursday. Cannot wait. Yes.
Do we have to actually like the day of the week?
No. How many times a year do I have? So for example, if every 10 days is a buffalaco day, how many times does 10 go into 365? Approximately 36, right? So there would be about that many times. Okay. So you do need to know there are 365 days in a year. You probably already know that, but if you don't, there it is. That's going to be helpful information for you. And then, we talked about this before. Why would it be foolish to ask you to find the least common factor of two numbers? Likewise, find the greatest common multiple. I've kind of switched the words around in the two concepts here, and it's foolish to ask you to do it the other way. Why is that? And then, time for review at the bottom as well. This homework is due tomorrow. You'll get your practice test for the first unit tomorrow. We'll go over it Wednesday, and your test on unit 1 will be Thursday.
Do we do help sheets in class?
You can do help sheets in class, at home, wherever. We're not going to do it together, like you're in charge of your own help sheet, but you can work on it in class, at home, wherever you want. But get your homework done tonight. Fix the bell ringer tonight. Have a great day, everybody. That's how you math. Like and subscribe.